Hello geometry students, my name is Jami Emigh, and this video is our discussion on section 12.3, Inscribed Angles. Inscribed angle C intercepts arc AB. So look at this figure here, angle C right here. This, you guys, this is an inscribed angle, okay? The vertex is on the circle and both rays pass through the circle. Now think of intercepted. This angle, this inscribed angle, intercepts the circle here and here. So this is called the intercepted arc. Okay, so two new terms from this slide right here. Inscribed angle, like this one, contrary to central. Okay, this one's inscribed, and this is the intercepted arc. Inscribed angle theorem says that the measure of an inscribed angle is half the measure of its intercepted arc. So here that is. I'll just show you an example. So B is definitely an inscribed angle, as you can see. So if I told you that this arc was, looks like maybe it's 80 degrees. Okay, remember measure, not length, in degrees. It's 80 degrees. That would mean that the inscribed angle that intercepts it would be half of that, so 40 degrees. Finding measures of inscribed angles. Find the measure of angle ABD. Okay, ABD right here is an inscribed angle, and we know that it is half the measure of its intercepted arc. The intercepted arc is AD, which has a measure of 124. So the inscribed angle we're interested in would have half of that, which is 62 degrees. All right, why don't you pause this video and give this one a try. Welcome back. Let's see how you did. To find the measure of arc EFG, if you came up with 180 degrees, you got it right. If you weren't able to come up with that, no problem. Let's think about the inscribed angle right here, angle EHG. Angle EHG measures 90 degrees, okay, 90. So I think of doubling it. So going to the arc, that would be 180 degrees. Okay, so 90 is half of the measure of the arc. All right, we got a couple more here. We're asked to find the measure of angle T, so that is this inscribed angle, and the measure of angle R, and that is this inscribed angle. And the only thing we've been given is that this arc right here measures 66 degrees. So let's try it again. Pause this video and see what you come up with. Welcome back. If you said that the measure of angle T is 33 degrees and the measure of angle R, is also 33 degrees, then you got it right. It's kind of tricky to see because they overlap. Let me just try to highlight just this one for you. So see how this inscribed angle, its intercepted arc is 66 degrees. So the angle would be half of that, 33. I'm going to erase that and show the other one separately. Here we go. This inscribed angle, it's intercepting the same arc. And that makes its measure half of 66, which is 33 degrees. What are the values of A and B? All right, pause this video. Give it a try. Welcome back. Let's see how you did. If you set it up as the measure of angle PTQ, angle PQT, there we go. The measure of angle PQT is half the measure of its intercepted arc, and we know that that is 60. That would mean that its intercepted arc would have to be 120 degrees. So we have 60 degrees there and a 120 degree arc there. Okay, we had one more variable. It is angle B, or B degrees, sorry. If you set that up as, let me erase the old stuff. I'm going to put the 120 right here though. That's from here to here. If you set it up that angle PRS, so this one, is half the measure of its intercepted arc. Now careful, let me try to change colors here. The intercepted arc this time starts at P and stops at S. You see that? Angle PRS intercepts this large arc like this. So it's half that measure. Well, that measure is 120 plus 30 more. So it's a 150-degree arc. So the inscribed angle is half of that, which is 75 degrees. Inscribed angle theorem and corollaries. Corollary 1. Two inscribed angles that intercept the same arc are congruent. And we actually just did this with an example. If this inscribed angle and this inscribed angle, if they intercept the same arc, then they're congruent angles. So you can mark them off as with geometric code as congruent angles. So whatever one of them measures, the other one measures the same. Corollary 2. An inscribed angle in a semicircle is a right angle. All right, so here's a semicircle. Here's our inscribed angle that intercepts the semicircle. And that would make sense because a semicircle measures 180 degrees. So the inscribed angle would measure half of that, which is 90 degrees. Last one, corollary 3. The opposite angles of a quadrilateral inscribed in a circle are supplementary. So inscribed, I like to think of putting that quadrilateral inside the circle and then spreading it out, or oh goodness, what's it called? Dilating it as much as you can until it maxes out and it touches all points on the circle. Then it turns out by corollary 3 that inscribed, here we go, opposite angles are supplementary. Sorry about that. Okay, so corollary 3 says that the opposite angles are supplementary. So let me show you that in the figure now. Opposite angles would be A and C. So those would have to add up to 180 degrees. Oh, they're not congruent. I shouldn't make them look like they're congruent. There we go. A and C would have to add up to 180 degrees. And then B and D are another pair of opposite angles, so they would also have to add up to 180 degrees. All right, let's practice with those corollaries. What is the measure of each numbered angle? Part A, we've got the numbered angle 1 right here. And so to find its measure, it should be something in degrees. So pause this video and see if you what you come up with. Welcome back. If you came up with 90 degrees, you got it right. This inscribed angle is intercepting a semicircle right there. So the semicircle measures 180, which makes ours measure 90. B, what is the measure of our numbered angle, angle 2 right there? Pause the video, see what you come up with. Let's see how you did. If you said 38 degrees, you got it right. Reason being, corollary 1, this inscribed angle is 38 degrees. This one is also intercepting the same arc, which means that it would also have to be 38 degrees. Whoops, 38, there we go. Theorem, the measure of an angle formed by a tangent and a chord is half the measure of its intercepted arc. Okay, so that's nice. It's consistent with the last formula where it's half the measure of the intercepted arc. Before it was for an inscribed angle, but this time it's an angle created by a chord and a tangent. Okay, so if your angle is created by a chord and a tangent, then its measure is half of the intercepted arc. Show one more time on this figure here. Here's the chord, here's the tangent, and that measure would be 1/2 the measure of this intercepted arc. Let's try it. In the diagram, line SR is a tangent to the circle at Q. Okay, so we know that this is tangent. We know that this is a chord. If the measure of arc PMQ equals 212, what is the measure of angle 1? Let's label that 212 on the figure. P to M to Q. So that would be this arc right here. Fortunate I'm in the same color. Let me switch colors. All right, so this inscribed arc right here, we know measures 212 degrees. And so we're being asked to find the measure of angle 1. Okay, well, we know that this angle formed by a chord and this tangent is half the measure of its intercepted arc. So if we take 212 and we divide it in half, we're left with 106. So this measure, or angle 2 right there, measures 106 degrees. Now, I'll give you a hint what to do next. 1 and 2 are a linear pair or supplementary. So go from there. What do you get for the measure of angle 1? If you said 74 degrees, you got it right. For this to be supplementary to 106, it would have to be 180 minus 106, which gives us 74 degrees. Okay, that will conclude our discussion on Chapter 12. My name is Jamie Emigh. Thank you for joining me, and I will see you next time. Have a good day.